Hello guys, so welcome to the today's daily LeetCode challenge. Today's challenge is maximum ascending subarray sum. This is the problem number 1800 of the LeetCode platform, and we have to solve this problem maximum ascending subarray sum. Okay. So in this problem, if you take a look, then we are given an array of positive integer nums, and we have to return the maximum possible sum of an ascending subarray in nums. So we have to return the maximum possible sum, okay, of ascending subarray. So first of all, we have to determine which is which component, which part of the array is a ascending subarray, okay, and then we have to determine the maximum possible sum of the you know of all the components, ascending subarray components. So to do that, what we will do that, first of all, we will figure out what is the length of the given array, okay, and then let's have one variable max, and whenever we are declaring max, we initialize with the minimum value. That is a rule, okay. And what could be a minimum value in the given nums array? The minimum value will always be a single individual number, and since we are at the you know onset of this array, so for us it makes the best choice for initializing max will be nums of 0. So if any number is greater than any individual number is greater than nums of 0, it will be that number, okay, assuming that it is a decreasing subarray, decreasing array. Then every individual number will be on its own will be a increasing subarray, and any particular number will be a candidate for consideration of this ascending subarray. So we will be initializing this with max nums of 0. So this is there, and then current sum, okay, current sum also will be initialized with nums of 0. Why? Because any single individual number on itself will be considered as a subarray, okay. And so you can think of this as a basic base step of the induction, okay. In mathematical induction, we verify the base step, so we initialize this as a base step, and then we will get into the loop, and in the loop we will initialize I with 1, okay. Already we have tackled this I is equal to 0 case by initializing max with the nums 0 and current sum with nums 0, and I can go till less than n plus I. Now the condition to check whether nums of I is greater than nums of I minus 1 will tell us whether it is an ascending array or not, okay. So this check is critical to know whether the array is ascending or not. Now since we are at any middle, any ith index, okay, just imagine we are at any middle index, and then at that index, if the ith in value is greater than I minus 1th value, then we will increment ith value, okay, and that increment will be adding the ith value to the current sum. So we are assuming that it is having the sum of the I minus 1th value, okay. Otherwise, if it is not greater or it is equal to, in all these cases this else will be, it will come to all these cases. If nums of I is not greater, that is it is less than or equal to nums of I minus 1, okay. If it is in all these cases, what we will do, that we will create a new sequence, and new sequence will be created by taking this sum is equal to nums of I, okay. So with this we have done our what we need to do, and now the thing is that at every iteration we need to check if the current sum value is greater than the maximum, so we have to update our max. To update the max, what we'll do, we'll use this math.max max current sum and store this back into max. Okay, and then we will return the max. Okay, so we will run this. Return max. Perfect. Let's submit this. Perfect. I hope you liked this solution. With this, I would like to end this video. Thank you. Thanks a lot. Happy coding. Best wishes.